Okay, let's unpack this. Welcome to the deep dive.
Great to be here.
Today, we're plunging into the absolute foundations of maths, arithmetic, number systems themselves.
Yeah, the real bedrock. We've got these sources that kind of walk through the building blocks.
Exactly. And our mission, really, is to pull out the key stuff, maybe some surprising bits, give you a shortcut to understanding why these basic ideas are so fundamental.
Think of it as going back to square one with numbers.
But looking at the why.
Right. So the sources start us off with the most basic, the ones you count with, 1, 2, 3.
Natural numbers.
Natural numbers, yeah.
And then, well, we add just one thing.
Yeah.
0.
Uh-huh.
Yeah.
And suddenly you have whole numbers. 0, 1, 2, 3. Seems small, but it's a big step mathematically.
Definitely. And the sources show the next expansion.
We're excluding the negatives.
Exactly. That gets you the integers. So like -3, -2, -1, then 0, 1, 2, 3.
And that stretches out forever in both directions.
Infinitely, yeah. On the number line.
Okay. But those are all, whole steps. What about the numbers in between? Parts of things. Ah, good point. That brings us to rational numbers.
Fractions, basically.
Pretty much. The sources define them as anything you can write as a fraction, like a over b.
Where a and b are integers.
And crucially, b, the bottom number, can't be 0. That's key.
Okay. Like 25 or 73.
Yeah, or even a whole number like 5, because you can write it as 51.
Or 0 even. 05 works.
Right. But as you hinted, not every number fits that neat fraction form.
Right. There are gaps, sort of. Points on the line that aren't simple fractions.
Exactly. And those are the irrational numbers. The classic example always given is the square root of 2.
You just can't write it as a over b.
Nope. Its decimal just goes on forever, no repeating pattern. Pi is another famous one.
So you take all the rationals, all the irrationals, mash them together.
And you get the real numbers. That covers pretty much every number you usually think about. Every single point on that continuous number line.
Okay, that makes sense. Types of numbers covered. What about properties? The sources mention primes.
Ah, yes. Primes and composites. Really fundamental for multiplication.
So prime numbers, greater than 1.
And only divisible by 1 in themselves, like 2, 3, 5, 7. They're the basic building blocks.
And composite numbers are the others. Greater than 1, but not prime.
Yeah, like 4, 6, 8, 9. They have other factors besides 1 in themselves.
And the sources pointed out something specific about the number 1.
Oh, right. That's a neat detail. 1 is actually neither prime nor composite.
It kind of sits on its own.
Exactly. It's unique in that way. It doesn't fit either definition.
Interesting. And we visualize all this on the number line, right? It shows the order.
Mm-hmm. Simple rule. Numbers get bigger as you move to the right.
Which feels a bit weird with negative sometimes, like -1 is bigger than -2.
Because it's further right on the line, closer to 0. It's all about position relative to 0. 3 is obviously bigger than -1.
Makes sense. Okay, quick pivot to operations. Adding, subtracting, multiplying, dividing, especially with positive and negative numbers.
Right. The sign rules are critical, especially for multiplication and division. The sources lay it out clearly.
Like signs mean positive.
Exactly. Positive times positive is positive. Negative times negative, also positive. Like mod of 5 times -9 is positive 45.
But if the signs are different,
Then the result is negative. Positive times negative or negative times positive both give you a negative. So mod of 5 times 9 is -45. That rule's consistent.
got it. And 0. It has its own special rules, doesn't it?
Oh, absolutely. Adding or subtracting 0 doesn't change a thing.
Multiplying by 0.
Always 0. Wipes everything out. 0 times anything is 0.
But division. Division by 0 is the tricky one. The sources were specific here.
Very specific. Dividing 0 by something non-zero, like 0 divided by 5, that's just 0. Easy.
Makes sense. 0 pizzas, 5 friends, 0 pizza each.
Right. But flip it. Try to divide by 0, like 5 divided by 0.
That's the problem area.
Yeah. The sources say it's not defined. Sometimes you hear infinity, but the core idea is you just can't perform that operation in the standard number system.
It's not a number you can find. Like what number times 0 equals 5?
There isn't one. It breaks the rules, essentially. It shows a boundary.
So, okay, we've gone from counting, added 0, negatives, fractions, even those weird irrationals, looked at primes, signs, the whole deal.
Yeah, all these rules and definitions, they seem simple maybe, but they build everything else in math.
They really are the bedrock. Every calculation, every theorem, it all comes back to this stuff.
Absolutely.
Which leads us to, well, a final thought for you, the listener. Thinking about that edge case, dividing by 0 being not defined. If this whole world of numbers is built on these clear rules, what does hitting that not defined wall tell us? Is it like a glitch in the system, or does it reveal something deeper about how mathematical structures work, maybe their inherent limits? Something to chew on.